Welcome students. Myself Mr. Ahirrao VA from the Department of Instrumentation and Control Engineering, मराठा विद्याप्रसारक समाजास कर्मवीर ॲडव्होकेट बाबूराव गणपतराव ठाकरे College of Engineering, Nasik. Here we are going to learn the measurement of electrical parameters like voltage, current, frequency and phase. Objective for this one is to learn the measurement of electrical parameters like the voltage, frequency and phase difference using the oscilloscope. Outcome: students will be able to make the use of oscilloscope for the parametric measurements like voltage, frequency and phase difference. In many applications, there is a need for the measurement of certain electrical parameters. Though current can also be measured, but as the oscilloscope is a voltage sensitive device, the unknown current must be converted into the proportional voltage by simply passing it through a standard and accurately known resistance. In this video, you will learn the measurement of AC voltage, DC voltage, frequency and phase difference. First, we will go for the measurement of AC voltages. The figure shows two different sine waves having the various amplitudes. From CRO, we can be able to measure only either peak to peak voltage or peak voltage. The waveforms shown are waveform A and waveform B. Waveform A is occupying 4.6 vertical divisions from negative peak to positive peak, whereas waveform B is occupying 2 divisions from negative to positive peak. Simple equation you have to apply. The peak to peak voltage is equal to vertical peak to peak divisions, which we can read from the scale of the oscilloscope screen, and that you have to multiply by the volts per division setting. Let volts per division control setting is at 0.2 volts. Then the peak to peak voltages in case of both the waveforms, that is A and B, are for waveform A you have to multiply 4.6 divisions by 0.2 volts, you will get 0.92 volts. And for waveform B, it is 2 into 0.2 equals to 0.4 volts. In this way, the oscilloscope will provide you the facility for the measurement of peak to peak or peak voltage. If you want to convert it into the RMS voltage, then you have to use later on the equation V RMS is equal to V peak to peak upon 2 root 2. If you have measured only peak voltage, then V RMS equals to V peak upon root 2. The next is DC voltage. DC voltage doesn't have frequency, means it is equal to 0, and hence it may occupy or it may get shifted from the reference one or ground line by some amount. So either there will be vertical upward shift or downward shift. Upward shift with reference to the ground line indicates that is a positive DC voltage, whereas the downward shift will indicate the negative voltage with respect to ground. Here we will go for the positive vertical shift. For DC voltage, the vertical shift in terms of divisions occupied will be measured, and then you have to multiply it by volts per division control setting, and that will provide you the magnitude or amplitude or the level of the unknown DC voltage. Let the volts per division setting is at 0.1 volts and number of vertical divisions, that is the vertical shift, is 3.7 divisions. Then the DC voltage will be 3.7 divisions into 0 0.1 volt per division, and it equals to 0.37 volts. In this way, by simply measuring the vertical shift with reference to the ground line, you can be able to measure very easily the DC voltage. The next parameter is the frequency. The frequency cannot be directly measured with the help of oscilloscope. For that one, first you have to measure the number of divisions, and then you have to multiply by the time per division setting. Or in another words, you have to first measure the time period the waveform will take to complete one cycle. Here in this figure also, two waveforms have been shown. One is A and second is B. The time period for waveform A is TA, which is shown at the top side, and the time period for B is TB. When you have to go for measurement of frequency, you have to first calculate TA and TB, and then you have to simply take the inverse of the same one or the reciprocal, and that will provide you the frequency of the unknown signal. The time period T will be equal to horizontal divisions per cycle into time per division knob setting. Then you have to calculate the frequency as the inverse of the time period, and hence you can simply write F is equal to 1 by T. For example, if the time period is equal to 6 divisions into the time per division setting is at let 0.2 milliseconds per division, then we will have the total time period will be 1.2 milliseconds. If you will take the inverse or reciprocal of this one, then you will get F is equal to 1 by T is equal to 1 upon 1.2 milliseconds, and that equals to 833.3 Hertz. In this way, by the sweep method, you can be able to measure the frequency. The next parameter will be the phase difference. When you have to measure the phase difference, one condition must be satisfied by two signals, or you may say two sine waves, and that condition is both the waves must have the same frequency. There are three different types of phase difference, or in another words, the phase may be leading type, lagging type, or it may be in phase. Again, considering the two waveforms, for the two waveforms, as they are occupying equal divisions, that is 8 divisions, then we can say the frequency will be same. But the phase difference will be the time elapsed between the commencement of any cycle, either positive or negative cycle of first waveform or second waveform with respect to the first waveform. As per the figure, there is 1.4 divisions between the commencement of positive cycles in case of both the waveforms. Let's see how we can calculate the phase difference. Whatever difference is there in the commencement of cycles, that is 1.4 divisions here, that is equivalent to the phase difference. We know that when the sine wave is going to complete one cycle, after that one, the phase will be 360 degrees or 2 pi radians. But as here there is a difference of 1.4 divisions, so that will correspond to 360 degrees upon 8 divisions into 1.4 divisions, and that equals to 63 degrees. In this way, with the help of oscilloscope, the parameters like AC voltage, DC voltage, frequency and phase difference can easily be measured. You may refer the two books. First one by A.K. Sohani, Electrical and Electronics Measurements and Instruments, and the second one by David Bell, Electronic Instrumentation and Measurements. Thank you.